everyone, welcome back. In this particular video, we will be discussing the problem find all anagrams in a string. What we are given is a string containing or consisting of non-repeating lowercase English alphabets, or you can say only letters from A till Z will be present in the first string, in the input string, and it will be having all the characters to be unique. No character, no letter will be repeating. What we have to do is we have to also take an input of array of strings. Additionally, apart from the single string, there will be an array of strings also. Again, each containing non-repeating characters. The task is to create a program that identifies and returns the string from the array that are anagrams of the given first string. So output, whatever anagrams will be there, should be in the lexicographically sorted order. That we will see later on. But the point is, let's take an example input and try to understand what is the problem statement actually asking us to do. First string, it will be a fixed string. It will not be having an array. First thing will be a fixed string, which is, let's say, ABC. Then there are three strings, that is the array, the size is of 3, and the strings are CAB, BAC, and XYZ. And now we have to check out of these three strings, what all strings are anagrams with ABC, and whatever strings are anagrams with ABC, that we have to add in the output in the sorted order and return the output list or the output array. The output is containing BAC and CAB in the sorted order because BAC is lexicographically smaller than CAB. But the point is how to check whether two strings are anagram or what is the meaning of anagram strings. So for that, let's take two strings which are ABC and CAB. These strings will be anagrams to each other, provided that after some rearrangement of the first string, you can form the second string, or after some rearrangements of the second string, you can form the first string. That is a vice versa. And rearrangements is nothing but the permutation. That is, you don't have to remove characters, you don't have to add characters, you just have to rearrange the order of the characters. So given CAB, what I can do is I can take the C and make it go to the last place and it will become ABC. That is first as the same as the first string. Or similarly, remove C from the last and add it in the front. It will become CAB. So you can make ABC become CAB, make CAB become ABC. Hence, they are anagrams of each other. Similarly, if I take the example of ABC with BAC, again, what you can do is remove this A, make this go in between B and C, and it will become BAC. Even if the string was not ABC, even if it was BCA or CBA, still you can do the rearrangement. That is, first make C go at the last, and it will become the original, the second string which you want. So let's take an example which is not anagram with the other string. How about the string ABB? Is it anagram with BAC? Of course not. Why? Even after doing any kind of arrangement in ABB, you can never have a character C in that arrangement because C is not present in the first string. So a very basic observation which you can make is if any character is present only in the first string and not in the second string, or vice versa, if a character is present only in the second string but not in the first string, then those two strings can never be anagrams of each other. How can you permute them and make them equal? Or you can say, even if characters are of same, that is, let's say, if I am saying since given the first string, given the second string, each character will be only occurring once. Let's say the first string is having A, B, D. The second string is having B, A, C. Since each character should be occurring once, B is matching with B, A is matching with A, but there is no C present in the first string or there is no D present in the second string. So these are not anagrams of each other. Provided the constraint, how you can check whether two strings are anagrams? You can maybe create a set of all the characters present in the first string. You can create a set of all the characters present in the second string. But let's solve it in a general way. Let's not take the consideration that all the strings characters are non-repeating. Let's take the case where even if the characters are repeating, still our logic should work fine. So how to do it? One very brute force way of doing it is just by finding all the permutations, but that will actually take a lot of time complexity, exponential time complexity. Because if I take a string which is ABCD of 4 length, how many permutations, how many rearrangements of strings ABCD can be possible? Are 4 factorial permutations at least are possible, where the output string or the second string which we have to compare with might be any from these 4 factorial. So in order to generate all those 4 factorial strings, you will have to at least do a time complexity of 4 factorial. That is n factorial, where n is a string's length. And then you have to do a comparison. So obviously it will, fairly you can say, it will go exponential in time. Might be some space complexity will also be involved. Having said that, is there any polynomial time complexity, that is n, n square, n cube, such kind of time complexity existing? The answer is yes. One thing is, if you will just think carefully among all the permutations or among all the anagrams of a given string, let's take ABCD. The permutations will be ABCD, ABDC, it will be ACBD, it will be ACDB. Similarly, it will be BACD, BADC, and so on. Given all these strings, how you can form it with the first string, or how you can convert the first string into all the other strings? How you can check whether they are anagrams? That is, since both of the strings will contain each characters same number of times, A will be present one time in first string. Let's take this one. A will be present one time in second string. B one time in first string. B one time in second string. C one time in first string. C one time in second string. D one time in first string. D one time in second string. Even if, let's say, this is A, B, C, D, 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 multiple characters, the second string should also have D 2 times. So what we can do is, since we want all the characters to be of same times, we can sort both the strings, because after sorting all the strings, what will happen is they will have all the characters in smallest to highest, or from lexicographically minimum to highest. So sorting ABCD will give you ABCD only. But even if you sort ABDC, it will still give you ABCD. That is sorted characters in alphabetical order. This will also give you ABCD. This will also give you ABCD. This will also give you ABCD. This will also give you ABCD, and so on. So all the anagrams or all the permutations of a given string, after that string is also sorted, after all those strings are also sorted, will give you the same string if they are anagrams of each other. But it is not true for the strings which are not anagram. Sorting ABD will give you ABD only, and sorting BAC will give you ABC. These are not equal. And you can compare equality very easily by comparing every character. So the point is, let's say there was an array which was containing BAC, CBA, and there was a string, I guess, XZY, something like this. And the original string, let's say CBA was there, or maybe CAB was there. And we have to check what all strings are anagram with the first string. Let's consider the array is of n length, and let's consider each string's length is L. So first of all, what we have to do is we have to sort each string, that is each string of L length sorting. If for sorting the first string, it will take the output form as ABC. This will also give you ABC. This will also give you ABC. This will give you XYZ. It doesn't matter what is the sorted array or the sorted string. What matters is sorting that string in term complexity will be L log L, L log L, considering each string is of the same length, L log L, L log L, where L is the length of each string. Now you can easily compare whether this is equal to this. Yes, so this is the anagram. Is this equal to this? Yes, this is also anagram. Is this equal to this string? No, this is not anagram. So whatever strings are anagram, just put them in the output. Don't put the sorted strings, but put the original strings. That is BAC and CBA. But also output should also be sorted. So whatever the output will have, sorted also. So if output can contain n strings, sorting the list of n strings will take n log n time. So overall time complexity to do this sorting based approach will be L log L for how many times? For n plus 1, n plus 1 times. You can say n times only. So each string sorting into n such strings plus sorting of the array will take n log n. Into time will be there, into length of the string will be there. But if we are saying that, provided that the constraint is saying that the string's length will be at max 26, each string will be only of maximum 26 characters, because there are only unique characters. What we can say is L is 26 only in worst case, which is constant. So overall, this thing will come out to be constant. So it will be n log n into the length, which is still constant, plus n, which will be n log n only. But is there anything better than n log n? The answer is yes, we can do better than n log n. Just that the fact is output still needs to be sorted. So output still need to be sorted in n log n time. But this first factor where we are doing the sorting of each string can be reduced. This factor of L log L can be reduced. And what is that approach? That approach is finding the frequency of each character in each string. That is what I will do is I will create a frequency array because I just need how many times each character is present. Or you can create a hash map also. Hash map will contain key value pair data structure. That is, keys will be the characters, values will be that frequency of that character. However, in the question, it is only mentioned each character will be present unique times. That is non-repeating characters. You can go ahead with creating a hash set also. But even if it is duplicate, then hash map will still be correct. So let's go with the hash map only. Put c comma 1 in that hash map, put a comma 1 in that hash map, put b comma 1 in that hash map. Similarly, create hash maps for each of these strings one by one, not at once, otherwise space will be a lot. One by one, while comparing whether they are anagrams, create the hash map for BAC. It will be b comma 1, a comma 1, c comma 1. And now you can easily check whether these hash maps are same or not. That is, compare c. What is the frequency? Is it 1? Is it 1? Is it 1? Yes. So these are anagrams. Similarly, check with this one. The hash map for CBA will also be c comma 1, b comma 1, a comma 1. But for XYZ or XZY, it will be different. So using the hash map based approach, using the counting of each word's frequency, what will be the overall time? To create this hash map, you will only require L time, L time, L time, L time. And for n such strings, overall time will be L into n, not L log L into n. Plus, or although we still need to output in a sorted fashion, that is, all those anagrams should be printed in increasing order, lexicographical order, we will still require n log n time. But the point is, if let's say the question was not asking you to sort the output, then this term will be not there in both the time complexities in the third approach, hash map based approach. So in that case, L times n will be better than n log L times n. That's why hash map based solution or the map based solution, hashing based solution is the best possible solution. What about space? Since we are going to create hash maps for each string, but there are only 26 such characters, so hash map will be of constant space. Even though it is extra data structure, still space is constant. So time will be L times n, where L is almost constant value because it is only 26. So it will be linear time constant space solution. With that, we are done with the second milestone, that is understanding the most optimized solution. Now we will do what? We will write the instruction manual from it. So what we have to do is create a hash map of characters as keys, and what? Values as, or integers as values for the first string, for the string str. And put all the key value pairs or put all the frequencies in the hash map. So how to do it? You will run a for loop, and maybe how you can do it. Instead of creating a hash map, let's just go with the frequency array because there are only 26 such characters. So create a frequency array of 26 size. Each will be containing integers, each having value, each element as 0 initially. It will be easier to implement. Now run a loop, a for loop probably, over each character of the input string of string str, and put the frequency, increment the frequency of character, increment the frequency of character in the frequency array by 1. That is, do the frequency plus plus. But ensure that whatever index you are taking, it should not be the same as character. Let's say if I'm saying increment the frequency of A, you should not go to the 97th index and do the frequency plus plus, because 97th index will not exist for a frequency array of 26 size. If you are creating, let's say only take A, B, C, D for now. If you're storing A's frequency at 0th index, B's frequency at first index, C's frequency at second index, D's frequency at third index, what you have to do is, you will have to check what is the character present in the string A, B, C. It is A. So go to the block of A, increment the frequency. Go to the block of B, increment the frequency. Go to the block of C, increment the frequency. But what is the block of A? It is 97 minus 97, that is 0. 98 minus 97, that is 1. 99 minus 97, that is the character minus the A character, or minus 97. So while putting the frequencies, this small thing which you have to make sure is index in frequency array should be what? It's the character minus 97, or you can say minus A, small a. Now that we are done with the frequency array of first string, do the same for every string in the list. So first of all, create an output list. Create a list of output strings, which will be initially empty. as empty list initially. It will be a dynamic list. And one by one, iterate over each list element of the input. Run a for each loop over over each string in input array. And again do the same thing. That is run the loop over all the characters of that string and find the frequency. So just copying the same thing, but this time for the string over the array. So we are saying if the string over the array is the string str2, then we have to run the loop over str2 and do the same thing. That is character minus a only. Okay. Now check whether these two frequencies arrays are same. So check if frequency arrays are same at each index at all 26 elements, then yes, the two strings are anagrams. That is, if both the characters are occurring same number of times in both the strings, yes, both the strings are permutation of each other or anagram of each other. And if such a case is there, then we have to add the output as the current string. Add the string 2 in the output list. So return the output list finally, but before returning, we have to sort the output because it is expected. Otherwise, your output will not match. So just use an inbuilt function to sort the list of output strings and then return the list of output strings. We will be discussing the code in Java programming language. So let's just directly jump onto it. First thing what we need as discussed is a frequency array. But since in the input there will be only 26 letters, the frequency array should be only of 26 size because there will be 26 different types of characters. So let's say frequency array we are creating of 26 size of integers. Initially each integer will be of 0 value. That is default value of integer is 0, and just store all the elements frequency from the string input string, that is str. So I will run a loop over all the characters. So maybe what we can do is we can directly run a for each loop over each character. So run a for each loop over each character by using the to-char array function, because you can't directly run a for each loop over a string in Java. In order to run a for each loop over a string, first take out the character array, or you can say convert it into a character array, and then run a iterator over that character array. That is, let's say the string was hello. So what we are doing in this is first we are taking HELLO inside a array of characters and then running the loop directly over characters. That is, first ch will be h, then ch variable will be ELLO, and so on. So what we are doing is for each character updating the frequency by plus plus. But can we just simply do frequency of character plus plus? The answer is no. We discussed it in the approach that if there is a character which is having the value, let's say small a, so it is having a ASCII code which is 97. And in order to make it store in the frequency array, we will have to store it at the 0th index or the 0th block of frequency array. So in order to convert 97 to 0, we have to subtract 97 from it. That is, subtract a itself from it. Similarly, for b, we will have to store it at first block, or you can say subtract 97 again. That is, subtract a again. So from any character, first subtract the value of small a, or you can say 97, go to that index and then do the frequency plus plus. This is how you are creating a frequency array. So you can just stop at this moment. You can try to run this code and see what is the output of the frequency array. But assuming that it will be correct, let's just do what? Let's just create frequency arrays for each string in the list that is in the array. So given the array, or you can say given the array list precisely, we will iterate over each string of that array list and do what? And check what is the frequency of that particular string. That is, do the same thing for that string as well. So run a for each loop over each string str. That is what we have done here. So let me just write it here and create a list of output, because we don't have to print everything in the output. We only have to print those strings which are the anagrams of input. So let's just create the output list also. Now what we have to do is, now we have to check that whether the current string is anagram. And in order to check whether the current string is anagram, again we have to do the frequency array concept. That is, run a for each loop over each character of str2. Let's say this is str2 because str1 is already declared, and do the same thing. That is, I will create a frequency array. Let's say this is now frequency 2 instead of frequency, and just run a loop every time over the string 2. Same way we did it for string 1. Instead of str, now we will be doing str2 and update the characters frequency in the frequency 2. So copy this and update the frequency in frequency 2. Now, once we are done with the frequency array of both the strings, we will compare whether frequency arrays are same or not. And in order to compare whether two frequency arrays are same, you can just first convert them into strings and compare those strings whether the strings are equal. So if the arrays dot toString, or you can also run a loop to compare. If arrays dot toString, the frequency array 1 is equals to the arrays dot toString, the second frequency array, that is frequency array 2, then it means yes, the two strings are having each character same number of times occurring, that is frequency array is same. And if it is such a case, then yes, the two strings are anagrams. And if it is that, then we will add it in the output, that is in the output list, add the str2, the current string. And finally, we will return that list. But as the question is expecting us to print all the outputs in sorted order, what we have to do is we have to first sort the list, the output list. So collections.sort the output and then return the output. That is the output only, not list variable. Okay. So let's see if it is going to work fine or not. Otherwise, if let's say comparing strings will not work, then what we will do is we will try to compare character by character. Or you can say we will compare each integer, whether each integer is having same frequency or not. So although right now, as you can see in the sample test case, it is working fine. So maybe directly comparing the strings, comparing the arrays directly, converting them into strings will actually work. Let's see if it is also working for the corner scenarios. And you can see it is actually working. So what is the overall time complexity of this code? First, we are creating a frequency array of the first string. Let's say the first string is of length n1. So this entire function, or this entire, you can say, code block is taking order of n1 time, because doing frequency plus plus is a constant operation. Then what we are doing is we are running a loop over each string of the array. So let's say array is of n length, and let's say each string is again of n1 length, or you can say n2 length. So order of n1 times because of the iterator over the string array. And then you can say for each string we are running a for each loop over the characters. So into n2, where n2 is the string length of each string inside the array. And then just we are comparing two strings of 26 size. So this is a constant operation. This is not related to n or n1 or n2 anything. Finally, what we are doing is after that, we are also sorting the output. So output can contain n strings. That is all the strings can be anagrams. So sorting it will require n log n. So overall, what is the time complexity? It is first was n2, where n2 was the length of the first string. Let's consider n1, n2 both as L only. So string length, every string, let's say, is of average length L. So first operation was L length operation. Next operation is n times L length operation, and then sorting all the strings of, you can say, n number of strings in the output will require n log n. So the overall time complexity will be L plus n into L plus n log n. Now that in the question it was mentioned that the length of the string will be very small, because in the input it was only mentioned each string will have at max 26 characters. So you can ignore this part, you can ignore this part, and you can simply say the overall time complexity will be n log n. But the point is, if it will be not a constant length of string, if it will be very large, then it will also introduce the term n times L due to this particular loop. However, right now it is the time complexity of sorting, which is overpowering everything else. But the code is very short, as you can see. And what about the space complexity? If we talk about frequency arrays, they are just 26 size arrays. So they do not require any extra space, or you can say constant space, even though they are auxiliary data structures. And when it comes to output data structures or input data structures, we generally don't include input or output in the extra space. So extra space actually for this entire problem is a constant extra space, or order of one extra space. So with that, we are done with the problem. Find all anagrams in a string. We will meet in a new video with a new problem. Till then, bye bye. Take care.